So Algebra 2, this is 8.7. We're going to model equations on exponential and power functions. So the first one, we're going to start off with exponential functions. And what we're going to do is we're going to use this equation here, y equals ab to the x, where a and b are constants that we have to find, where y and x are the ones that are going to change. Basically, we're going to be given 2 points like I have here, and what I need to do is go back, fill it in for x and y twice, creates a system, solve the system. So we need to find a and b in our system. So all you're going to do is take your points here, 1, 6, and 3, 24, and plug it in for x and y. So the first one will look like 6 equals a times b to the first. And the other one is 24 equals a times b to the third. Okay? Now we have to solve for a and b. We're going to solve for this using substitution. So what I'm going to do is take one of these and solve it for a or b. On our power function ones, I think it'd be easiest to solve for an a value so we can sub it in. So if I wanted to solve for a in this first equation here, I just have to divide both sides by b. So I'm going to divide by b, divide by b. So I think everyone should agree that that would be 6 over b. Everybody see that a would equal 6 over b? And once I've solved, I'm now going to substitute that into the other equation, right? So I'm going to put that in for a. So 24 equals 6 over b times b to the third power. We okay with this? And then we need to simplify. I've got b on the bottom, but I got b to the third on top right here. Look at this. So can't I take b cubed divided by b, and you'd get what? Because really this is over 1, right? Can you guys agree with that? So it'd be 6 times b cubed on top and b on the bottom. So I'm going to end up with 24 equals 6b squared. Because a b would cancel on top and on the bottom. And then you just got to solve for b.
Wait, why is it b squared?
Because b cubed here divided by b. Divide by 6. I think you get 4 equals b squared, and you solve for b by taking the square root. Now, under normal circumstances, to solve for b, I'm taking a square root, I would probably have to say plus or minus, right? But we're talking about an exponential function. Your base number, b, will never be negative. So therefore, b is equal to 2. These numbers will not always be nice. You may end up with 2.38. Okay, so be mindful of that. Now that we know what b is, plug b into here, where we're solving for a, to get a. A equals 6 over 2, which is 3. So we just found a and b. We are not done, because we have to write this as a function. And so our function is y equals a, which was 3 times b, 2 to the x. And there is your function. It's kind of a little bit all over the place right now, because I was running out of room. But there it is. Our a and b we found. The exponential functions, I think, are a little bit easier. Pretty easy, straightforward. Also, when you're solving your equations here, Like, remember we have two equations?
How do you know which one you're going to plug in?
Yeah, so this is what I was to say. Whatever has the smaller exponent on B, solve for that one. So solve for A on this one because B to the first power is smaller than B to the third power. So solve this equation for A. Now we'll do power functions. Power functions are slightly different. Now x is the base and b is the exponent. So the actual base will change according to whatever x is. Same idea. You start off by subbing in your x and y's from your points into the equation. So 5 equals a times x to the second, right? 9 equals a times x to the 6th power. I just made a mistake, guys. I was doing what we did last time. X is what needs to be put in. X was 2 to the x, sorry.
That's what I plugged in, but
And this would be 6 to the x. No, 6 to the b's. Oh my goodness, I did it again.
Mr. Common Chat.
So, all I did was put in for x and y. So now we have it right. X is in the x spot, the y's are in the y spots. Now we have to solve for a and b using substitution again. Again, a, if you notice, a is kind of by itself in both of them. So I think it's be easier to solve for a. Again, on these ones, choose the smaller,
They both have the same
no, the smaller x value. Okay, so in this case, I'm going to divide both sides by 2 to the b, right? So a equals 5 over 2 to the b power. This value is going to be placed in for a. So 9 equals 5 over 2 to the b times 6 to the b. When I do this, do you guys recognize that we have, you guys can't see that, that we have 6 to the b on top and 2 to the b power on the bottom? They have a common power. That's the power of a quotient. I can do that in reverse.
Would it be like 3?
Maybe 3 to the b. Right. Why? Because it becomes 9 equals 5 times 6 over 2 to the b. I can pull that b power off of both of those pieces, and it leaves a fraction of 6 over 2, which then becomes a 3. And yesterday, or the day before, we solved equations like this. You divide both sides by 5. And we end up with 9/5 equals 3 to the b. So we got 9/5 equals 3 to the b. What do I do from here? How do I get b to the bottom? Hit it with a log. Log base what?
B.
Not b. 3. Log 3. Log 3, right? Because these will cancel each other, which leaves us with b equals log base 3 of 9/5. I don't necessarily like that. I want a number, so I'm going to use the change of base. And if I use the change of base, switching the order here, I can take the natural log of 9/5 divided by the natural log of 3. Take your calculators out. 0.0535. 5. Now that we have B, we need to find A. And we said A was, from over here, 5 divided by 2 to the B. 5 over 2 to the B, which would be 5 over 2 to the 0.535. It's going to be a decimal again, isn't it? And 3.45. So now we have A, we have B. We need to plug it into y equals ax to the b. So y equals 3.45 x to the 0.4535. And that's how you do those.